let's get back to where we were. All right, now what about if we want the desired margin of error? So once again, your boss tells you, construct a confidence interval and be this confident. Okay? How many samples would we need? So remember that every single confidence interval in the world is estimate plus minus margin of error. Now we're looking at X bar plus or minus T star times S over root N. So the margin of error is everything back here. So if we know how big we want this margin of error to be, what should our sample size be? So let's take a look at these cute little monkeys right here. Okay. Previous study involving this variety of monkeys suggests that the standard deviation is about 5. What is the minimum number of monkeys that we would need to research to have a margin of error of 1 milligram per deciliter? So they're telling us researchers want to estimate the mean cholesterol level of this particular type of monkey. They would like their estimate to be within 1 milligram of the true value mu at 95% confidence level. So we need to figure out how we're going to do this. So T star, we don't know what N is. So when we're solving this for the sample size for the desired margin of error for quantitative data, we're just going to use Z star. So at 95%, if we look at our table here, at 95%, it's 1.96. So we know our Z star or T star we're going to use is 1.96. That is T star. S, they tell us, is 5, and we don't know N. And we want this to be less than or equal to 1. So now I'm going to multiply 1.96 times 5. So let me bring my calculator in here this time. So I'm going to quit out of here to go back to my main screen. I want 1.96 times 5. Okay, so I have 9.8 over the square root of n has to be less than or equal to 1. Okay, now let's multiply both sides of the equation by the square root of n. So if I multiply both sides of the equation by root n, these will cancel out. Now I'll have 9.8 is less than or equal to square root of n. Well, how do I get rid of a square root? Oh, I square it. So now I'm going to square 9.8, and I get 96.04. So n must be greater than or equal to 96.04. But when we're talking about a sample size, we cannot sample 0.04 of a person. And if I only sampled 96 people, it wouldn't be large enough. So when solving for n, for a desired margin of error, we always round up. So n must be greater than or equal to 97 monkeys to make sure that our margin of error is 1 deciliter at 95% confidence.